product is thermodynamically favored and will probably be favored in the product mixture if the base is sterically unhindered. So let's look at a couple of examples to see what's going on here. So let's look at this substrate. We're reacting with methyl oxide. So just to go back to the mechanism stuff, we know that this is a tertiary substrate, so we cannot do SN2. This is a strong base that is relatively unhindered, so we could do SN2 reacting with methyl oxide. So just to go back to the mechanism stuff, we know that this is a tertiary substrate, so we cannot do SN2. This is a strong base that is relatively unhindered, so we could do SN2.
So that is relatively unhindered. That is relatively unhindered. So that is relatively unhindered. That is relatively unhindered. So that is relatively unhindered.
Or E2, however, we just resubstrate, so we cannot do SN2. This is a strong base that is relatively unhindered, so we could do SN2 or E2, however, we just said SN2 is impossible, so relatively unhindered, so we could do SN2 or E2, however, we just said SN2 is impossible, so we know we're going to do E2, we know we're going to do an elimination. However, there are multiple protons that can be extracted that would yield different elimination products. So let's draw some of the implied hydrogens in. Let's say if we got this one, grab that, double bond there, lose the bromine, we're going to get this product, right? The double bond will be here, leaving group leaves, so that's what we would get. However, double bond there, lose the bromine, we're going to get this product, right? The double bond will be here, leaving group leaves, so that's what we would get. However, we could also...
So that's what we would get. So that's what we would get. So that's what we would get. So that's what we will get. So that's what we would 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 get. So that's what we will. So that's what we will get. So that's what we will get. So that's what we would get. So that's what we would get. So that's what we will get. So that's what we will get.
So extract a double bond there. Lose the bromine. We're going to get this product, right? The double bond will be here, leaving group leaves, so that's what we would get.
So that's what we will get. So that's what we will get. So that's what we will get. We would get. We will get. So that's what we will get.
However, we could also extract a proton from this methyl group up here. So if we did that, we would get this product here. So what is the degree of substitution of these products? Well, over here, the left carbon has two alkyl groups. The one on the right has one and the implied hydrogen. So that
the one on the right has one and
so what is the degree of substitution of these products? Well, over here, the left carbon has two.
Over here.
Alkyl groups. So what is the degree of substitution of these products? Well, over here, the left carbon has two alkyl groups. The one on the right has one and the implied hydrogen.
The one on the right has one. The one on the right has one. And the one on the right has one. The one on the right has one. The one on the right has one. The one on the right hand has one. 제가 light 하잖아요. The one on the light has one. 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 So
what is the degree of substitution of these products? Well, over here, the left carbon has two alkyl groups. The one on the right has one, and the implied hydrogen. So that is a tri-substituted alkene. Over here, this carbon has two alkyl groups, the two sides of the ring, and this has none. Those are the two implied hydrogens. So that is a di-substituted alkene. Tri-substituted versus di-substituted means this will be the Zaitsev product.
This would be the Zaitsev product.
And this will be the Hoffman product.
The Hoffman product.
And in this case, the Zaitsev is going to be favored because it is more thermodynamically favorable, and it's a relatively unhindered base. So it's going to have access, it's going to have roughly equal access to this secondary proton as it would to that primary proton. So in this case,
as it would to the primary proton.
And it's a relatively unhindered base. So it's going to have access, it's going to have roughly equal access to this secondary proton as it would to that primary proton.
That would have なんとか access to this secondary proton as it would to the primary proton. なんとか access to this secondary proton as it would to the primary proton. To this secondary proton as it would to the primary proton. To this secondary proton as it would to the primary proton. As it would to the primary proton. To this secondary proton as it would to the primary proton. To this secondary proton as it would to the primary proton. As it would to the primary proton. To the secondary proton as it would to the primary proton.
So in this case, the Zaitsev, and it's a relatively unhindered base. So it's going to have access, it's going to have roughly equal access to this secondary proton as it would to that primary proton.
As it would to the as would to that.
And it's a relatively unhindered base. So it's going to have access, it's going to have roughly equal access to this secondary proton as it would to that primary proton.
As it would to the primary proton. As it would to the primary proton. As it would to that primary proton. As it would to that primary proton. As it would to that primary proton じゃなくて as it would to that primary proton. As it would to that primary proton. As it would to that primary proton じゃなくて as it would to that primary proton. 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 To the secondary proton, as it would to that primary proton.
So in this case,
in this
the
case,
Zaitsev
the
product
Zaitsev product
is going to
is
dominate.
gonna
We would
dominate.
still
We
get
would
some
still get
Hoffman,
Hoffman,
but we'd be looking
but
at
we'd
the
be looking
majority
at
to be
the
Zaitsev.
majority to the
Now,
Zaitsev.
if the base
Now,
was significant, so in this case,
so in
the
this
Zaitsev
case, the
product
Zaitsev
is going to
product is
dominate.
gonna
We would still get some Hoffman,
dominate,
but we'd equal access
equal
to this
access
secondary
proton
proton as it would to that primary
as it
proton.
would to that
So in this
primary
case, the
proton.
Zaitsev
So in this
product
case, the
is going to
Zaitsev
dominate.
product is
We
gonna
would still get
dominate.
some
We would still
Hoffman,
get some
but
Hoffman,
we'd
but
be looking
we'd
at
be
the
looking at-
majority to
we'd be looking at majority. We'd be looking at
be Zaitsev.
majority
Now,
of Zaitsev.
if the
Now,
base
if the
was
base
significantly
was
sterically hindered, so
significantly ejected, significantly ejected, significantly.
such as say terbutoxin. So in this case, the Zaitsev product is going to dominate. We would still get some Hoffman, but we'd be looking at the majority to be Zaitsev. Now, if the base was significantly sterically hindered, such as say terbutoxide, then we might expect the Hoffman product to be able to dominate, even though it is less thermodynamically favorable, because kinetics would then drive that reaction. A terbutoxide would be able to access this proton with much more ease because there would be a lower activation energy associated with that acid-base reaction. Now, let's look at something like this here.
Let's look at something like this here.
Let's say we're using methoxide again. Now, the thing with the cyclic systems is we're going to have to draw with that acid-base reaction.
Thing with the cyclic
Now,
system.
let's look at something like this here. Let's say we're using methoxide again. Now, the thing with the cyclic systems.
Now, the thing with the cyclic system. Now, the thing with the cyclic system. Now, the thing with the cyclic system. 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 こういう The thing with the cyclic system. 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 The thing with the cyclic system.
Is we're going to have to draw the chair. So I went ahead and drew that. So here's the chair. There's that isopropyl click systems. Is we're going to have to draw the chair. So I went ahead and drew that.
I went ahead and drew that. I went ahead and drew that. I went ahead. I go ahead. Go ahead. Don't come again. I went ahead and drew that. Draw. I go ahead and draw that. Don't come again. I went ahead and drew that. 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 I went ahead and drew that.
So here's the chair. There's, let's say we're using methoxide again. Now, the thing with the cyclic systems is we're going to have to draw the chair. So I went ahead and drew that.
Went ahead and drew that. Went ahead and drew that. So I went ahead and drew that. Went ahead and drew that. Went ahead and drew. Went ahead and drew that. Went ahead and drew that.
Let's say we're using methoxide again. Now, the thing with the cyclic system is we're going to have to draw the chair. So I went ahead and drew that.
So I went ahead and drew that. I went ahead and drew that. こんなにアンドって読んでないんだよね。アンドが went ahead and になっちゃう。went ahead and drew that went 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 ahead and drew that.
So here's the chair. There's that. Let's say we're using methoxide again. Now, the thing with the cyclic system is we're going to have to draw the chair. So I went ahead and drew that. So here's the chair. There's that isopropyl group extending upwards. There is the chloro group there. There is the methyl group going down there. So now the reason we had to draw the chair.
Now the reason we had to draw the chair. So now the reason we had to draw the chair. So now the reason we had to draw the chair. So now the reason we had to draw the chair. The reason we had to draw the chair. Now the reason we had to draw the chair. Now the reason we had to draw the chair.
There is the chloro group there. There is the methyl group going down there. So now the reason we had to draw the chair is.
So now the reason we had to draw the chair.
There is the chloro group there. There is the methyl group going down there. So now the reason we had to draw the chair is because we have to be able to see which protons are available for elimination. Now we know that we're going to have to extract a proton from a carbon adjacent to the carbon that bears the leaving group. So that means a proton from here or a proton from here. But as we learned before, we have to have that proton that's eliminating anti to the leaving group. And on this carbon, it's
シクロアルカンのハロチカンシクロアルカンのイーツ反応ではアンチペリプロナル関係にないと脱プロトンできないよっていう話をしています。
But as we learned before, we have to have that proton that's eliminating anti to the leaving group. And on this carbon, it's the isopropyl group that's anti to the leaving group. So this proton is not available for elimination. That's anti to the rest of the ring. So this one's no good. We're not going to get elimination there. Over here, we do have two protons. So even though this one's not going to work out, this one will do just fine. Because if we drew the Newman projection, we would see that because they're both axial, those are anti to one another, and that's where the elimination is going to occur. So let's see that. So in this case, we're only going to get one product, and we don't have.
We only gonna get.
To analyze site D, that. So in this case, we're only going to get one product, and we don't have to.
We're only gonna get one product. Get じゃなくて get. In this case, we're only gonna get one product. in this case, we are only gonna get one product.
Analyze Zaitsev versus Hoffman, whereas you might think that you would have if you just went based on the top-down view. It would be very possible to draw in this implied hydrogen there and assume that that was available for beta elimination, just as one of the ones on this carbon. But when we draw the chair, we see it is not the case. We do not get a mixture of Zaitsev and Hoffman product, and assume that that was available for beta elimination, just as one of the ones on this carbon. But when we draw the chair, we see it is not the case. We do not get and assume that that was available for beta elimination, just as one of the ones on this carbon. But when we draw the chair, we see it is not the case. We do not get a mix and assume that that was available for beta elimination, just as one of the ones on this carbon. But when we draw the chair, we see it is not the case. We do not get a mixture of Zaitsev and Hoffman products. We get ones on this carbon. But when we draw the chair, we see it is not the case. We do not get a mixture of Zaitsev.
Not the cultures. We do not
and Hoffman products. We get only one product, and that is the di-substituted alkene there. Ones on this. It would be very possible to draw in this implied hydrogen there and assume that that was available for beta elimination, just as one of the ones on this carbon. But when we draw the chair, we see it is not the case. We do not get a
But when we draw the chair, we see it is not the case. We see it is not the case. But when we draw the chair, we see it is not the case. But when we draw the chair, we see it is not the case. But when we draw the chair, we see it is not the case. But when we draw the chair, we see it is not the case. But when we draw the chair, we see it is not the case. 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 But when we draw the chair, we see it is not the case. But when we draw the chair, we see it is not the case.
Mixture of Zaitsev and Hoffman products. We get only one product, and that is the di-substituted alkene there.
シクロール間の脱流で椅子型配算を書かないでいつも書いてる椅子型配座じゃない単純な構造式から脱流をしようとさせようとするとシストランスの関係なんていうんだアンチペリプラーナの関係になかったとしても抜いちゃう間違って抜いちゃうから椅子型配座に直して両方アクシャルの状態アクシャルの状態でこっちがハロゲンでこっちが水素だったらこう電子がこう倒れてきてこっちが抜けるで二重結合が作れるよっていう話をしてました。